Hello everyone, welcome to the sixth video in the Assembly Language Primer for Hackers video series. Now in this video, we will go ahead and look at how to move data between CPU and registers and memory in an assembly language program. So the first instruction which is of importance is the move instruction, and the usage format is very simple. Move source into the destination, right? So there are three variations depending on the size of the source and the destination. The first is move L, which is used to move a 32-bit value. So in this example, move L EAX EBX, what this means is move and copy the value of EAX into EBX. However, EAX itself is not changed in this instruction. The second variation is move W, in which you move a 16-bit value. So in this case, we move a 16-bit value, which is the AX register, into the BX register. Similarly, move B is actually for an 8-bit value. So now let's move on. So how to go about actually transferring the data? Now there are various ways in which the data transfer might happen. The first could be between registers itself. In this case, depending on the size of the register, we would use the appropriate move instruction. So now, because we are transferring between a 32-bit register into another 32-bit register, we will use the move L instruction. So move L EAX, EBX. The second variation is moving data between registers and memory. Now let's say we have an integer defined by a label location. Now how do you go ahead and move the value in EAX into that location? This is simply achieved by using move L EAX, location. Now the point to note is that depending on the size of the location, the appropriate register needs to be chosen. So let's say if this was a short int, then in this case we would probably have used the AX register. Similarly, to move data from a location into a register, we use move L location, register. Now do not worry if many of these things isn't very clear at the moment. We will look at a dive demo once we go through the slides. The third variation is actually moving an immediate value into the register. What this means is move the value 10 into the register EBX. In the fourth variation, we have moving an immediate value into a memory location. Now let's say we have a location which is a byte containing value 0, and you want to transfer the value 10 into this byte. How would you do that? You would use the move B instruction, because all you want is a byte to be overwritten, and then you mention the value 10 and then the location where it needs to be copied. The fifth variation is actually using indexed memory locations. Now this is something which is slightly interesting and tricky. So if you remember in the previous video, we had defined an integer array and it contained 10, 20, 30, 40 and 50. Now how could one go ahead and selectively, let's say, copy a value into the third element, which is 30? Now in order to do that, the way in which we need to mention that to the assembler is basically by mentioning a base address, open up brackets, mention the offset, the index and the size. Now this isn't as complicated as it might sound. So let's take this as an example. So the base address in this case, of course, is where integer array starts, and hence it is integer array, right? The offset into the integer array from where we want to start. So let's say we want to start from the beginning, in which case the offset is 0. The second argument is the index into the array. Now what we really want is to go ahead and start from the beginning of the third integer, which would be the end of the second integer. Hence the index would be 2. Finally, the size of the objects, given that it's an integer, would be 4. So what this does is that it points to the memory location where the integer 30 begins. So what will the instruction movl EAX into integer array 0 to 4 do? It would go ahead and copy the value of EAX into the current memory location where the value 30 is. Now we will look at all of this in demonstrations, so don't worry if you're confused at this point. Finally, indirect addressing using registers. Now, this is somewhat synonymous to the pointers analogy in C. Basically, if you have a label and you want to find the address of the label, you need to prefix $, before that label. So let's say there is a label location which is a byte. If you want the memory address of location, then you just have to write $location. Now how do you go ahead and transfer the address of a location into a register? Very simple. Take the address, move it into the appropriate register, in this case EDI. Now let's say once you do this, basically EDI contains the address of location. Now if you want to move a value, let's say 9, into location using the EDI register, then the way you would do it is actually using the mover instruction, then the immediate value, and then you have the EDI register inside the brackets. What this actually signifies is that do not copy the value 9 into the register EDI. Instead, copy the value 9 into the address pointed by the value in the EDI register. So in this case, the value inside EDI register is taken. It is a memory location, and now 9 is actually copied into that memory location. Similarly, now if let's say you want to copy various values at an offset from a particular memory location, how would you do it? In this case, what one needs to do is go ahead and prefix this particular bracket and the register with that offset. So let's say if you wanted to place the value 9 in memory location pointed to by EDI plus 4 bytes, the way you would mention it is 4 bracket open and inside the EDI register. Similarly, if you want to place the value 9 in memory pointed to by EDI minus 2 bytes in memory, then you would go ahead and prefix it with -2. So we'll look at all this in the video demonstration. So now let's go into the demo. I've created a very simple demo script. So this is exactly the same as that was in the previous demonstration in the variable demo. Now I've added various move instructions, right? So let's go ahead, compile this program and go through this one by one. So let's compile the program first. Let's link it. And let's run it. Now the program just runs and exits, so it's not much helpful right now. Let's go ahead and load it in GDB. Once it's loaded, let's go ahead and hit a breakpoint somewhere. So let's say we want to begin tracing from this instruction itself. So let's go ahead, create a breakpoint. And now let's run the program. Now if you notice, the program has hit the breakpoint. Now let's kind of look at the code and see what should happen. So the first instruction is actually moving an immediate value into a register, which is the value 10 into EAX. And this is what is going to be executed now. So let's actually look at info registers to see what is in EAX right now. So if you notice, EAX currently has the value 0. Let's step through the code and execute this particular instruction now. So the instruction has been executed. Now let's look at info registers again. And now if you notice, the value 10 has been transferred into EAX. Now this was exactly what was there in the instruction. Now in the next instruction, which is move W50 into int16, right? So the interesting part here is because int16 is just 2 bytes, we are using the move W instruction. So the first thing we need to know is exactly what is there inside int16 right now. So how do we find that out? So once again here we use the examine memory command. So we go ahead, examine the memory, and what we really want is to be let's print the value in decimal, and let's go ahead and print this as a half word and give int16 as the memory location. So if you notice, right now in int16 the value is 3, and this was something which we had assigned previously, right? So now the instruction basically is going to copy the value 50 into int16, right? This is the next instruction. Let's see if it works. So the instruction has been executed. Let's examine the same memory location, int16, and if you notice now the value 50 has been copied. So this is how the immediate value can be copied into a memory location. Now let's look at the third variation, which is moving data between registers. So in this example, we are going to move data from the EAX into the EBX register. So let's do an info registers first. Look at what is there in EAX. Well, the value 10 is there, which we had copied previously. And right now, EBX is vacant. So let's step through it. And let's look at the registers now. And sure enough, both EAX and EBX are now 10. So this is the demo for the move data between registers. Now in the fourth case, it is moving data from memory to a register, right? And first what we need to do is look at what is there in the int32 memory location. So once again we use the examine memory command, and currently in the int32 location we have the value 2. So this should be copied into EAX, which currently has the value 10. So let's step through the program, and now let's look at the registers again. So if you notice, the value 2 has been copied into EAX. The fifth variation is actually moving data from the register to memory. So this is interesting. So the first thing we'll do is let's actually go ahead and copy the value 3 into the AL register. So let's step to that piece of code. And now let's go ahead and copy the value in AL, which is going to of course be 3, into the byte location label, right? So let's actually look at what is there currently in byte location. Once again, we use the examine memory command. And the current value in byte location is actually 10. So this is exactly what we had stored previously when actually initializing byte location. Right, so now after the instruction is executed, we should have the value 3 in byte location. Let's step through the program, look at byte location again, and sure enough, we have the value 3 in byte location. The next demo is the integer array 1. So this is interesting, as we've noted. Let's say the integer array currently has the values 10 to 50 in them. We want to replace the value 30 with something. Let's see how we can do it. So the first thing which we need to understand is that we can only mention the location where things need to be copied by mentioning the base address, which in this case is the integer array location. Then we have the offset from that base address, then the index, and then the data size. So the way this will be computed is base address plus offset plus index into data size, right? The catch is that both offset and index need to be mentioned as registers. However, data size can be a numerical value. So let's actually go ahead and transfer the value 0 into ECX, the value 2 into EDI, and then run this query where we go ahead and transfer the value 22 into the third array element, which is currently 30, right? So let's actually see how this looks when executed. So first let's look at the array. So if you notice, we have the values 10, 20, 30, 40, and 50. Now let's run the various instructions. So you copied 0 into ECX. Now we are going to copy 2 into EDI. And now we are finally going to move the value 22 to replace 30. Let's actually now examine the memory again. And if you notice, the value 30 has been replaced by the value 22. So this is an example of how we can go ahead and move data into an indexed memory location. Finally, we have the indirect addressing scheme using registers. So what we can do is, let's first go ahead and copy the memory location of int32 into EAX. So first let's look at the memory location of int32, sorry. So this is the memory location. Now when we actually step through the next piece of code and then look at registers, you will notice that int32's address has been now copied into EAX as expected. Now the next line of data is actually going to copy the value which is present in the address contained inside EAX into the register EBX. So what happens is, this is the address in EAX, and the value which is present in this address is actually int32, and that is going to be copied into EBX. So let's actually examine exactly the value in int32 right now. The value is 2. Let's step to the program and now look at the registers again. And if you notice, the value 2 has been copied into EBX, right? Now in the next step, what we do is we go ahead and copy the value 9 into int32 by going ahead and using an indirect addressing scheme using the EAX register. So what this instruction means is, copy the value 9 into the memory location which is currently pointed by the EAX register. So let's step through the program. And if you notice, now if we look at the int32 memory location, it contains the value 9 which has been copied. The rest of the code is just the exit syscall, so we can just continue the program and exit. So well, that's all for this video. I wanted to demonstrate various ways in which you can move data from registers and memory locations. This is probably a very, very important building block if you want to understand and code in assembly language. I would strongly recommend that you download the piece of code from this video page and try all this out yourself. Also, I would request you to leave comments behind in the leave a comment link below. This will really help me improve in my next videos, as well as provide me encouragement to keep making these videos. Well, that's all. Thank you. Hope you like this video.